Okay, you upload the formula sheets. Let me check Saurav. Very good. Hmm. Okay, good, good, guys. 1 second. And please maintain. And team, you can download as well. Okay, so let's start today's sessions. And I think we understood what's meant by overfitting, guys. What is meant by overfitting? And if we train the model with more attributes, then what type of problem comes? Overfitting problem comes. How to reduce overfitting? How many techniques we discussed yesterday? PCA and dimension, and then we have called feature selections, cross validations, and ensemble learning. All those things we
Recording in
discussed.
progress.
Right. So let's go ahead and we can continue rest of things. So just one moment. From today onwards, we're going to start algorithms. And the first thing, if the dependent variable is continuous, then we can use regressions algorithms, right? And if the dependent variable is binary, then we use classification algorithms. Okay. So as we start, let's understand advanced statistics. We understand what is ANOVA, guys? Analysis of variance. In analysis of variance, what are things we see? A sum of square regressions, sum of square error, sum of square. I mean total SST. R square. What is R square? Adjusted R squares. These are the measures to check regressions part, guys. 27th. So let's welcome to regressions part. In the regressions, we also called as regressions model. Some of when you attend interview, someone says regressions model, or some of them talk about regressions algorithms, but both represents to same. Both represents same info. Am I clear? The first thing. And the first algorithms which we covered today, April 27th, is called simple linear regressions. Okay. In simple linear regressions. Now, the next one. In simple linear regressions, the name itself indicates simple linear regressions. What is the formula? We study y equal to mx plus c. So in y equal to mx plus c, how many independent variable and how many dependent variable? How many dependent variable? Y is only one dependent variable and only one independent variable. M equal to, what is M, guys? Slope. M equal to slope. And C equal to constant. I hope understand what's meant by constant. And all these things are explained in advanced statistics. Advanced stats, no problem. So regressions have split into two parts. regressions has split into two parts. The first one is linear and second one is non-linear. Are you understand, guys? The first one is linear, the second one is non-linear. In the linear, we have simple linear regression algorithms. Understand? And the second one is multiple linear algorithms, guys. And the third one is called gradient descent. And the fourth one is called stochastic gradient descent. The regression is split into two parts. One is linear and another one is non-linear. The linear, we have simple linear regressions, multiple linear gradient descent, stochastic gradient descent, and batch gradient descent. Right? And then we have lasso regularizations, or we call it as L1 regressions, or we call like L1 regressions or lasso regressions. And then we called ridge regularizations, and then L2 regressions or ridge regressions. So all these algorithms comes under linear part. In non-linear part, we have support vector regressor and decision tree regressor. And then we have random forest regressor. And then we have k nearest neighbor regressor. Then ANN, artificial neural network regressor. And then we have SVM XGBoost regressor. We have plenty of things, but up to this that's fine. Decision tree random forest. Even clear? First, we'll complete linear, then we complete non-linear. Once we complete two linear regressions parts are completed, so machine learning is called supervised learning. What we guys call supervised learning. When the data is structured, then we used supervised learning algorithms. In interview, if someone asks you, can you please name some of the supervised learning algorithms or structured data algorithms, you talk about all those things. You called regressions algo and clustering algo. Clear? Okay, so let me repeat again. We start today's sessions with regressions, and regressions called regressions model, also regressions algorithms. Okay, and regressions means what? Y equal to mx plus c. And in machine learning, we call it supervised learning, and we understand supervised learning from today onwards, guys. And the first concepts of supervised learning is regressions part. In regressions is split into two parts. One is linear and one is non-linear. So linear, we have simple linear, multiple linear, gradient descent, stochastic gradient descent, batch gradient descent, lasso, and ridge. In non-linear, we have SVR, decision tree, random forest, KNN, and ANN, and XGBoost. Understand? Okay. Let's go. So the first topic we use called simple linear regressions. Just one moment. I am remove this. Okay. In simple linear, we use one independent and one dependent variable. First, listen to me very carefully. And first we talk about math, a little bit of this one. Assume I have two data points, X and Y. How many data points, guys? So we have X 1, 3, 2, 4, 3, 2, 4, 4. Can we plot this or not? 1, 3. Can we plot this? This is 1. This is 3. 1 and 3. 2 and 4. This is 2. This is 2 and 4. X is 2. Y is 4. X-axis is 3, Y-axis is 2. X-axis is 4, Y-axis is 4. And X-axis is 5 and 5. Can we call it actual data or predicted data? Is this actual data, guys? Actual data Y or Y hat? Y or Y hat? Y. Understand up to this? So in the data set, we have one dependent, we have one independent variable. So what algorithms we implement then? Simple linear regressions, because the equation is y equal to mx plus c. Close this. Next one. If I take a mean of x, I got 3 and 3.6. If I take a mean of the x and y, average 1 plus 2 plus 3 plus 4 plus 5 divided by 5, the mean is 3 and 3. Let's plot the data point. Can we plot the mean or not? Clear? And in the equations, y equal to mx plus c, we have y values, we have x values, isn't it? We have y values, we have x values. But how to compute slope? So the formula of the slope is summation x minus x bar, y minus y bar divided by x minus x bar whole square. When I used scikit-learn algorithms, so this formula is called in the backend. And assume, guys, we have 5 records, so we can take pen and paper and we do computations, isn't it? But what happens if you have 2 lakhs rows? Would you do that? It's highly impossible. So that's why the sklearn packages are take care of it. The sklearn packages take care of this one. Are you understand? So here, how to compute slope? Summation x minus x bar, y minus y bar. Can we follow this? X minus x bar, 1 minus 3 minus 2, and 2 minus 3 minus 1, 3 minus 3, 0, 4 minus 3, 1. Can you do this or not? Okay, great. Now y minus y bar, 3 minus 3.6 minus 0.6, 4 minus 3.6, 0.4, 2 minus 3.6 minus 1.6, 4 minus 3.6, 0.4. Clear? X minus x bar into y minus y bar. Now x minus x bar whole square, minus 2 whole square, 4, minus 1 whole square, 1, 0 whole square, 0, 1 whole square, 1. Understand, team? When we solve this, 4 by 10, m equal to 0.4. So if slope equal to 0.4, can we get the slope? That means the mean, we get the C point or not? Constant line, which is called 2.4 here. In the questions, the constant is given. And also, if you have mean and the slope, this will connect some point or not, guys? So then this would be the slope, which is called 2.4. Team, understand up to this? So in this one, so we understand how to find out. So what is slope equations? In the data sets, we have X and Y. M, we calculated. C is constant, 2.4. Okay. Now, the data set which I showed you, is it history or not? Historical data. This is historical data. Go ahead to the next one. Let's follow this. These data points are actual or predicted? Actual. I will open another one. I meant to say that. Just what is mean squared error, guys? What is mean squared error? I will tell you, actual minus predicted is called mean squared error. So here, and let's open this one. Just 1 second. Okay. Then, all right. So let's go back to here. What is X bar and Y bar? Man, it's average, man. X bar and Y bar is average. Very simple. From that time onwards, I'm saying 1 minus 3 x minus x bar, xi, 1 minus 3 x bar, y bar. Clear with? Understand or not? Okay. All right. Next one. Now I wanted to say this. What is the slope we got? 4. What is constant? 2.4. And the formula says y equal to mx plus c. You know this one. Now clear this one. Let's model predict. The model is built. What is the model? In the model, I got slope equal to 0.4, c equal to 2.4. X is independent variable. This is y. And let's call y hat. Let me create y hat. This is called y hat. Actual data. Now let's how model predicted. The equation is y equal to mx plus c. Y equal to what is m we got? 0.4 x plus c. Now assume y equal to y hat equal to 0.4 into 1 plus 2.4. Actual is 3. Model predicted how much, guys? Can I say model is predicted? 2.8. When I plot the data point, can I get the data point somewhere here or not? Now let's say in second row, y equal to 0.4 into 2 plus 2.4. What is the model predicted? This is predicted table or not? This is actual table. Now let's consider y equal to mx plus c. M is 0.4 into x is 3 plus 2.4. We got 3.6. And then 4.0. And then 4.4. 8:30 a.m. batch. Are you understand or not? It's very simple. So here, let me close this one. Now go to the next step. If I go to the one moment, Control G. In this Control G, this is y. And the red points are y hat. The error is minimize or high? Very, very minimum. What about this data point? Actually 4, but simple linear regressions model predicted 3.2. So what is loss functions then? What is loss functions? What is loss functions, guys? Actual minus predicted. So this is called residual. We called OLS, ordinary least squared, MSE, mean squared error, loss functions, cost functions, anything we call. So 3 minus 2.8. The error is 0.2 or not? 0.8. But look at this. So in the second observations, actual is 4. The model predicted 3.2. So the error is quite high. In the third, actual is 2, but my model predicted 3.6. There is high error or not? And the fourth row, this is 4 and this is excellent predictions, right? Actual and predicted both are same. But in the fifth row, we have actual 5, but my model predicted is 4.4. Did you see what I'm trying to say? If I connect all the lines, sorry, this line is called best fit line. This line is called, and the equation of the line is y hat equal to mx plus c. Now let's assume, so why I'm teaching you all those things? This is my historical data, guys. In historical data, I have only 5 rows, right? Let's assume in future, if someone work experience is 10, can the model is predicted or not? How? Y equal to mx plus c. So if y equal to mx plus c, y is equal to what is slope? 0.4 into 10 plus 2.4. What is output, guys? Let's assume sum of 40 value, something like that. Means we never train the data with 10. Listen to me. We never train the data with 10. With historical data, I build my model. That model which predict the future or not? That model is predict the future. I never trained the 10, but model predicted what is the accuracy of the 10. So let's assume the model predicted 40. The model predicted. So let's say there is an experienced employee whose experience is 10 years. And if you join a company, the company pays him 40,000, 40 lakhs rupees. Let's assume in future, an employee visit to the company. His experience is 10. If company pays 38 lakhs, the model is gives good predictions or not? Guys, are you understand? So if you do, what is benefit of that? Benefit is company has a vision that this year the company has this much of revenue generations. Based on that, they will expenditure it. So 38 lakhs, can we give it to them or not? It's also an important topic. So I hope you understand. So this is theoretical part. We understand math behind it. Are you guys clear or not clear? So in this sessions, online team, everybody's understand. Online team, everybody understand. So how to find out? Let's have a look at this. So distance between actual and predicted. Yes. So this is called, if I ask you an interview question, the interview question, let's assume I can plot multiple line like this. Okay. Out of multiple regressions line, which line is best fit line? How do you answer, guys? This is also simple linear, but which one is best? Which one I call best fit line? The one which has less error. The one which has less error. That one, very good, Sashi. So, I mean, low error line. I mean, less error. Minimize MSC. Yes, low MSC means square error. That one we considered as a best fit line. Are you clear? This is what concepts, nothing else. This is what concepts, simple linear regressions. We understand the math behind it. Now we understand theory. Let's heading toward one practical, and I'll give you one of the situations based round, and let's see, are you guys fix it or not? Okay. All right. So just one moment. I can go ahead. So everybody's cleared these concepts or not? What is the math behind simple linear regressions algorithms? Very simple. I'll explain one more time. So here, see guys, I request don't join late. A lot of things you missed. Okay, and you never understand. We have these data points X and Y, and we take a mean of these data points. Once we take a mean, let's assume this is the formula for it. X minus X bar into Y minus Y bar, X minus X bar whole square. Now let's go ahead. And when we check, the mean is, I hope you can find out. X bar means average, isn't it? Y bar means mean of X axis, mean of Y axis. And we calculate the formula. Once we compute the formula, we got output as 4/10. And once we plot the slope and once we plot the line, we can get a constant line, which is 2.4. Now let's predict if we pass this y equal to mx plus c. We have actual table. Now I created y hat. Now I created y hat, isn't it? These are, and y minus y hat is finally when I plot the data point, y hat data point, and if I connect all my predictions point, this is called best fit line. Clear up to this? Very simple. I'll give you one of the data sets to you. And okay, let's assume this. I have one file which is called housing data set. My questions to you is, how many attributes we have? We have 21 columns. How many columns, guys? 21 columns. Let's assume you wanted to buy the house. You wanted to buy the house. The name of the project is House Price Predictions. What is the name of the data sets, guys? House Price Predictions. So before you buy the house, what are the important factors you check? Does the house, what is that, when exactly the date they show for sold the house? What is the price of the house? 3 BHK, 3-bedroom house. What are the bathrooms and what are the square feet living? I mean, we check the square feet or not? and then square feet allotment and build up area and constructed area. We have all these things. How many floors, whether it's first floor, second floor, third floor. Waterfront, does the house has waterfronts? Does the house has any view like backyard view, beach view, all these things? Conditions of the house, whether it's third owner, first owner, second owner, something like. I mean, every building has, some of the corporations has given some grading of the house, isn't it? And square feet, and we called as RERA approved, all those things. I hope you understand or not. So those concepts we call. Does the house has basement? When exactly the house built on? Does the house is new or renovated? What is the zip code, latitude, longitude, and square feet living and square feet allotment? We have almost like, isn't it? Before you buy the house, don't you think these attributes you will check, yes or not? Okay. So all these attributes you must need to check. But my questions to you, I have 21 attributes. How many attributes? Which is dependent variable? Price. Excellent. We clear. Is this regressions or classifications? Why? This is continuous because some of the house cost is 22 lakh 20 and might be 53 lakhs, might be 18 lakhs, something like that, isn't it? But my question, why is clear. In this one, can we implement simple linear regression algorithm? Yes or no? I'm saying the simple linear regressions algorithm's equation is y equal to mx plus c. Understand? We can use one dependent, then only we can implement simple linear. But my question to you, in this data sets, I have 21 attributes. How many attributes we have? 21 attributes. If I have 21 attributes, can I implement simple linear regression algorithm? Yes or no? Yes. So she said, but will not be accurate. What about others? Yes or no? Okay. No. Paul says no. Saurabh said yes. Prasanna said overfitting. Nagesh said no. Okay. Before I get back to the projects, okay, and I'll have one small, just one moment. Let me close this. And home. Okay. So before that, I'll give you one small data set. First, we build the model, then I come back to it. Then this is the task for you, right? This is the task for you, how exactly you predict. And I will compare each and everything, but try to understand. I'll give you a lot of first projects. I gave you resume project called bank risk analysis. After complete regressions, there is a project called price prediction. This is live projects. This project has never death. You take any items in the world, price is important factors or not? Okay, maybe you take house, maybe you take car, maybe you take flight price, ticket price, food price, Tata car price, okay, stock price. I mean to say that when you understand these algorithms you can plant in the projects and you can showcase on your resume. Walmart sales forecasting, isn't it? And seasonal sales forecasting, fruit, your business, your dad's business forecasting, your uncle's business forecasting. Are you guys getting my point? Why we've been understanding all those things? So let's go ahead and I'll give you a small examples. Might be you see the data sets, but still, I want you to make things easy. And then we go back to the heading to most important part. I mean to say that, just one moment, I can open it. And I have one data sets. So let's assume, let me open the salary data. And if in the organization, some of employees are working, isn't it? Some of the employees are working, and these are experiences of an of an employees. So if an employee experiences 1 and 1 means 1 year 1 month, his salary is 39,000, guys. All right. And if another employee's salary is experience is 1.3, his salary is 46,000. If an employee experiences 1.5, his salary is 37. Can we continue like that? this data set has two variables. One is independent, one is, which one is dependent? Salary. Which one is independent? Now let's go back. Can I say y? This is x, and I implement this formula, y equal to mx plus c. How to implement? And we can build the formula. I mean, we can build the projects as well. Very simple. To we can use scikit-learn. Which one we can use, guys? sklearn for this one. Just minimize. See, man, Arjun. So for this data set, how we can judge if forecasting is going to be correct or wrong? You just wait, the situations will tell. Let's assume you have a like a big billion day, right guys? In big billion day, first day, you predicting the iPhone cost is 50,000. Understand or not, Arjun? Answer for you. In the first day, you predict the iPhone cost is 50,000. Maybe. So first day. Now, when the first day opens, if the iPhone cost is 50,000, your prediction is accurate or not? Now, Arjun, are you understand your answer? I mean, how can you judge? You cannot judge, buddy. Time will judge, isn't it? Let's say in the news channels, they will say, in Hyderabad, there is a chances of rain tomorrow. What happen if the rain come? Then the prediction is accurate. If the rain not comes, there is no harm. Machine learning models never gives you harm. Are you understanding? Okay. So here, very simple. I have to explain a lot of things. Just one moment. Okay. So the best part of Spider is it's a variable explorer. Immediately we can explore the variables. In Jupyter, you need to scroll down, isn't it? And need to remember the variables. So that's why the very simple. I hope you know what is the first step, guys. Import the necessary packages like NumPy, Pandas, and Matplotlib. One moment, guys. Just one moment. Let's go ahead to NumPy, and then we called Matplotlib, and we called Pandas. This is by default, okay? And then I'll call my data set. I think I have some of the, just copy, and I can change this to, 1 second, guys. And let me check this with the salaries we have. We don't have any missing values here. So even though, see, rather than you ask questions, I'll give you concepts. I'll give you every task, guys. You get to know each and everything. So data sets, we have 30 rows and how many columns? 2 columns. Can I split the data or not? From the data set, if I remove, this becomes my independent. If I remove this, then this become dependent. Okay. Now let's close this. I can split the data independent and dependent variable. So let's go to the data and let's go to independent and let's go to dependent. Clear, guys? Split the data sets. This is called split the data set. Once we split, what is the next step? Train test split or not? We can implement to train test split. What is the split ratio? 20%. Random state is there or not? Definitely you have to mention random state. So once we go ahead and let's split the data to training phase and testing phase, means out of 30 records, how many records for 80%? 24 records goes to 80 or not? And I'm sorry, 24 go for 80, 80 percentages, 6 records go for, testing, right? We split the data X to X train, X test, and Y to Y train and Y test. Understand, team? Next one. Just go to the next one. Very simple. To build the model, whatever the math formula we see today, whatever the math equations we understand, everything has loaded in from sklearn.linear underscore model import simple linear regressions. That's it. The moment when we call this package all the formula inbuilt it's calling, guys. Are you understand? So if I start my car, so engines are process automatic or not? The same way. So that's what most of people say is you no need to be required data structures much. Okay, Paul, if you give random state 5 or 6, see, I will tell you later all those things. Okay, Paul. There's a random state is another topic. I will tell you in classifications. What are the type of random state? How do we pass all those things? The moment when I start my engine, car engine, so the engine pre-processed automatic. You never see from where it comes, where it starts. Are you understand? The same way in machine learning, if you call the scikit-learn package, there is a packages called simple linear regressions is automatic. I mean, that's what I called sklearn is combination of data structures, algorithms, math equations, stats API, everything. So the moment when we called, just go ahead, sklearn.linear model import linear regressions done. I wanted to explain this one. So if you type here regressor, oops, I not defined. One moment, linear regressions, and I will click this one, select this. One moment. Did you see linear regressions? Ordinary least square linear regressions. What is meant by ordinary least square? Difference between actual and predicted. Fit intercept. What is meant by fit intercept? True. And normalized, deprecated. I mean, all those things, system defined parameters. You don't need to touch anything. Okay, I don't want to do any hyperparameter tune in here, guys. You can do fit intercept change true to false, but linear regressions, what exactly it does, it will control I. Guys, when you practice, you must need to get these help options. This is very important. If you not get, try to execute control I. Understand which one, guys? Control I. Linear regressions fit a linear model. Are we fit a linear model or not? In today example math part, did I get a linear model? Why yet when I connect all the predictions point, I got my best fit line. So here, minimize the residual, isn't it what I'm saying? We try to minimize the residual. So this minimize the residual sum of square between observed target in the data set and targets predicted by linear approximations, isn't it? And normalized. This parameter is ignored when fit intercept is set to false. If true, the regressions will be normalized before. Guys, I hope understand. I mean, I don't want you to get into deep. The one which I'm saying, please understand that, then things would be fantastic. So here, and n jobs and positive boolean attributes coefficients of array. What are the coefficients? Y equal to, who can give you the coefficients? The package itself take care of all the coefficients, guys. The packages itself take care of all the coefficients. Let's do this, and I can create a regressions here. And the moment when I call regressions, this is linear regressions I build or not? Which model I build? Linear regressions. We need to train the data. If I train the model with all attributes, what type of problem comes up? Overfitting. Regression dot fit x train and y train. Are you understand, guys? Means whatever the parameters I have, let's fit this linear regression algorithm to x train this data and y train this data. Are you understand or not? Very simple. I call this is my linear regression algorithm, which I'm calling from sklearn.linear model. I create a identifier and I call my algorithms. Let's fit the data to X train and Y train. Once, so we build the model with X train and Y train. Still, we left X test, Y test is left or not. So this model is accurate or not. I wanted to pass X test data to the model. What is the model? Regressor is the model. I wanted to how to pass regressor dot predict. What methods we have, guys? Dot predict method. When you click, we can find all the methods. Regressors dot predict X test. The moment when we click this, the Y pred is generated, guys. Now, there is Y pred is pending and Y test is pending. Which is actual, which is predicted data now? Which is actual, which is model predicted, guys? So assume, so this is called, I mean, 1 second. Let's call the data set. This is actual data. This is Y test is actual because we split the data into X train, X test, Y train, Y test. This is my actual data. This is predicted data. What is the residual now? What is residual, guys? Error 37 minus 47. What is the error, guys? Let's say 3K, 3000. In this one, 122, almost like less. I mean, I can say like 300. And what about this? Like 700, something like that. Do you see actual Y minus Y hat is called error. Now, if I plot the data point in visualizations, can we get best fit line or not? But here, assume I wanted to say one more thing in the data set, 37,730K. If an employee salary is 1.5, I'm sorry, if the employee experience is 1.5, okay, actual salary is 37,000, but my model predicted 40,000, guys. Did you see? But my model predicted 40,000, isn't it? Now 122, where do you have 122? Just go ahead and 122. So if an employee experiences tenure in 3 months, his actual salary is 122, but my model predicted 122,391 as well. Actual, I'm sorry, predicted. This is predicted 122,700. Do you see, guys? I hope you understand. So, and finally, let's plot these parameters here. I wanted to plot scatter plot among X train, Y train, and red color, isn't it? Because we train the model X train and on Y train, isn't it? And X train regressor dot predict X train color blue. I wanted to plot the Y pred line. So Y pred equal to regressors dot predict or not? Okay, and then plot dot title experience and X level and Y level dot show. This is very simple. Just one moment. When you check this out, right click and copy maze. Let's just wait. I have another data set, house price predictions. Okay. And I can say paint. Just bear with me. Control V. So X train and Y train, how many data points we have, guys? X train, Y train. The data split into how many data set? Out of 30 records, 80% mean 24 or not? We have all the points at 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24, somewhere this one. Yeah, we have this one. 2 times we have. So this is called 24. We visualize the training set now, but we need to visualize the set or not, guys? So let's go ahead and we can visualize the test set over here. And I can find out this one as well. Instead of training, I pass X test, Y test. Rest of things are same. Just go ahead and do this. Copy and I can plot this. How many records in the test set? 6, 1, 2, 3, 3, 6. Do you find any error? Residual is high or minimum? How do you say this? How many data points are predicted accurate? Do you find any outliers? No, we don't have any outliers. Actual predicted is perfect. Very less. It is a good model or not, guys? Is it called best fit line? Now assume, are you clear, team? So this is a very simple explanations. I mean, this is very simple code and all those things is done by a scaler. Now go to the next project, minimize it. I show you one of the data sets right now. I show you one of the data set and this data sets contain house data.csv. In the house data.csv, we have price. My question, can I implement simple linear regression algorithm to this data? Yes or no? How many of them say yes? How many of them no? No. Okay, Sasi said no. Yes, we can. Arjun said yes, we can. Saurabh said yes. Okay, let's understand. And very simple. The first one, NumPy, Pandas, Matplotlib, we make this, guys. Clear or not? Why don't, if I take space in this data one, if I considered y as my price, can I consider this attribute as x or not? I mean to say, square feet living, can I take x? I can ignore rest of them. I can ignore rest of the attributes. So this would be x and this would be y. So that's what I can say. From the data sets, I create a variable and I can say, I call my data set and space equals to data set from the data set square feet living. Can we get independent variable or not? Now price, if I split to the price, can I get my dependent variable? So can we implement simple linear equations? Perfect. Now here, np.array reshape -1, np.array price. Very simple. What is the next one? From sklearn.model selection train test split. Test size 1/3, random state 0. Can we build the model or not? Linear regressions, X-train. Let's predict and let's visualize the data. Let's visualize the data. I hope. Wait for a second. You can check many things, guys. Datasets.columns. I mean, you can explore more these two projects, guys. You can explore more things to these projects. I hope understand. And when we go back, let's open image new tab. Let's open image new tab. Now, did you see in these data sets we have few outliers or not? Because in the test data sets, I mean, is it impact? Now, this is what interview question is. If you find the outlier, how to detect? I will give you a small task. The task is, okay, how many data points we have? 1, 2, 3, 4, 5. No, not this one. I can say only 4 point. Only 4 point. I want you to use your brain. I want everybody to write the code here. Just one moment. To write the code, and this code gives us, can you please print the 4 records which are outlier? I need code for it. Can you do this? How to do this? Entire today, use your brain. And let's argue with the Google. And let's try to do this. Now the next step, maybe you can find out 4 points. Maybe you can find out, let's assume I can say, and also that's fine. This is also best fit line because the data spreads more, but we try to understand simple linear regressions. I give you one projects and this is training data. I don't want to get outliers because we build the model, but in test data, I have 1, 2, 3, 4. 4 is outlier points. Can you write a code? And this is what interview question is, how to detect outlier. If you detect outlier, what is the next step? This is the next step. And once you find out, can you please, write the code to print 4 outlier points. Once you print the 4 outlier points, what happened? You can immediately, drop an email and with the 4 records and say, these are the outlier points we have. And what I can do, can I eliminate or I keep it? Are you guys understand? So please, this is all those things. Yes, sir, error. This is not error, but outlier you detect a lot. In one area, if entire house cost is 50 lakhs, one house is 3 crore, definitely it is outlier, guys, isn't it? So how to detect outlier? When you mention this code, in interview, somebody asks you how to, if you find the outlier, what have you done? What have you done to the projects? Now, can you explain or not? Once you find out the 4 records, and you can immediately shoot an email to your management. You can ask their permissions. What I'm going to do? Can I eliminate? If you eliminate, you build the model by removing 4 attributes. That's one conditions. Or in the code also, you can create a new slicing data frame and you can 4 attribute. Many things is possible. Yeah, you can do this, Yamini. I need code. Can you do this? IQ, or I don't think so you get. That's not the proper technique. That's what I want you to research in ChatGPT, research in Google, and get me know. This isn't task for you. So today, 1 algorithms we completed. What are the name of the algorithms, guys? Simple linear regressions algorithms we completed. We understood math behind this algorithms, and we understand equations. As the linear, the best fit line is linear line or not? If the best fit is linear line, what is equations of this line? Y hat equal to if I x to the power degree or not? If I change x square, this becomes non-linear now. So we have some set of non-linear algorithms, guys. We have some set of non-linear algorithms. What are the set of non-linear algorithms I mentioned in the sheet? So can you do this, team, everyone? So there's a few things I wanted to assign. And once I want you to do this one. Let's close. I will share the data set. I will share this assignment to you, and I need to do a few things from you as well. And once we're done, and next one is called multiple linear regressions. But before I go ahead to the multiple linear regressions, tomorrow, whatever projects, statistics we done or not, I will show you all the practicals tomorrow. All the statistics, whatever you learned, we talk about that tomorrow. And before I go ahead, I wanted to close one more topic today, which is called very, very important, feature selection technique. What exactly techniques we have? Feature selection technique. We have 3 techniques, guys. Always remember. Feature engineering technique, feature selection technique, and feature scaling technique. Never be confused of one technique to other. Arjun, it's not been shared yet, Arjun. Once it is done, I will share to you on this one. Okay. I will share the group, the workshops. Okay. I will check with them. And once I find the deep learning workshops, I'll share to you. Okay, guys. Okay. So there's 2 things. What is feature engineering technique? What is feature selection technique? Feature scaling technique. So the feature engineering technique, how many techniques we saw? This is called EDA technique, guys. We have 7 techniques we understand or not? How many technique we understood? 7 technique. Then we have called feature scaling technique. I think we haven't completed. This is called normalizations, or I call as min-max scaler, and then we called it standardizations, right? And then we have called feature selection technique. The interview question, how to select the right attribute from the data set, is important. If I show you the house price data set, rather than I pick price, if I pick ID of the house, does the business is understanding or not understand? Never understand, right? So that's why how to feature selection technique. The first one, to identify the feature, the first important concept is business understanding. And then second one is data mining concepts. What is meant by data mining concepts? In data mining concepts, we have 3 methods. One is filter methods, one is wrapper method, and one is embedded method, guys. So we have three methods to detect the feature selection. How to select the feature means in a cricket domain, which attributes are very, very important to team win the match or lose the match. I understand. In students' career, which are the important attributes to student pass the score with good percentages? And I can add with many of things, guys, but this is one of the concepts, and I wanted to talk about this quick feature selection techniques. We have three techniques. Listen to me. And this is PC also one of the techniques or not? Principal component analysis. We got eigenvalue and eigenvector. What is the formula? Covariance matrix minus lambda I equal to 0. So the lambda is eigenvalue, and if I try to apply the quadratic equations, then I get my eigenvector, isn't it? And those, the highest vector would decide as a PC1. And instead of you train all the attributes, I can train the PC1, and then we can implement here. So we have three methods. The first method, we have filter methods. The second one is wrapper, and the third one is embedded. In the filter method, we have informations gain, chi-square test, correlation coefficient. In wrapper method, we have recursive feature eliminations, very, very important. Genetic algorithms not required, decision tree. I mean to say that informations gain, I will explain at decision tree. Are you clear? Now, chi-square test, I will tell you tomorrow. Correlation coefficients. What is a positive? What is a negative correlations or not? Can we identify the attribute with the help of correlation? Yes or no? How? If we find positive correlations, can we consider the attribute? Yes. If we find negative correlations, can we consider the attribute? Can we eliminate the feature? Yes or not? So what is the concepts we're studying right now? Feature selection technique. With the help of correlations, are we select the feature? Yes or no? By the help of heat map, can we find out the right attributes? Are you understand? Great. And wrapper method, recursive feature eliminations. We have two concepts. One is forward eliminations, one is backward eliminations. These concepts I'll show you practical tomorrow. Entire data science projects, if you're trying to eliminate the features, we try to do PCA technique or this one, feature eliminations technique, guys. Embedded method, decision tree. Decision tree, I will explain later part. So at this moment, today, I will informations gain decision tree. You can, I mean, at this moment, you can skip, but in decision tree regressions and classifications, I can explain you. Correlations, we already covered. Understand. Recursive feature, I'll explain tomorrow. Just understand chi-square test. What is filter method? Filter method is just identify the, build the model with relevant attribute is called filter method, guys. What is meant by chi-square test? Chi-square is one of the statistics. Where did you see this formula in statistic journey? Anybody? Where did you see the statistical formula? Sort of. What? Which one? G score. G score, isn't it? G test. No, it's not G test. It's a Z score. In G score, if I convert my normal distributions to mean 0 and standard deviations 1, then we call standardized variable or not, which is called G score. So G score is chi-square test, guys. And this is also Pearson correlation. Pearson is the scientist who created this test. That's what we called as chi-square test. Understand? Just I'll give you a small example, but in practical, we don't use this. In practical, we used only two technique, but these are for theoretical understand. And so here we use PCA and backward eliminations. Understand or not? Most of the attributes, if in the data sets, if you have more feature, you cannot build the model with all the features, guys, or else what problem comes up? Overfitting. So when overfitting comes, we get less accuracy. So that's why to reduce overfitting, the first thing, business understanding. Once you understand business, you can eliminate some of lot of attributes. Clear? And then second one, PCA. Still, client says, no, I don't want to remove any attributes. I wanted to use PCA technique. Okay. And still out of PC, even though it's done, I wanted to know which one is very important. Then I want to use backward elimination technique, and we compare with p-value, guys, and we compare with p-value. I'll come back all those things tomorrow. And this one, are you guys clear or not? So here, chi-square test. The chi-square of normal variable is not chi-square variable. For example, I'll give you very simple. This is the formula, guys. Chi-square test is a statistics formula. I'm saying, assume I'll give you small examples. Table shows number of aircraft accidents occurred during days of a week. I mean to say the test whether these accidents are uniformly distributed or not. I understand or not? These accidents are uniform distributions. Did you understand or not? What is meant by uniform distributions? If we get a line, I mean equal line, so that's called uniform distributions. Monday, 14 accidents. Tuesday, 18 accidents. Wednesday, 12 accidents. Thursday, 11 accidents. Friday, 15. Saturday, 14. Sunday, 14. So total, how many accidents happened, guys? 98. So 98 divided by 7 is 14. So here this is the question. In this questions, DF equal to 6, x squared 0.005. What is meant by 0.05? If you're 95% confident, then 0.05 is error or not, alpha. And let's assume x squared 0.05 is 12.592, isn't it? But let's say this. To check uniformly distributions, you need to check these conditions. If x squared is less than x squared 0.05, then what happened? The accidents are uniform. The accidents are uniform. If x squared is greater than x squared 0.05, then accidents are not uniform. I mean to say that, let's apply the formula. Observed value, expected value. This is actual values, 14, 18, 12, 11, 15, 14, isn't it? What is expected value? So 98 divided by 7, because we have 7 days in a week. So total, how many accidents? 98 accidents. 98 divided by 7, which is 14. So O minus E, 14 minus 14, 0, 18 minus 4, 4. And can you do this or not? Now O minus the whole square, 0, 16, 4, 9. O minus the whole square divided by E. When you follow this, the answer, we got 2.14. So 2.14 is definitely less than, what is the value, guys? 12.592. That means the accidents are uniformly distributed, because if you see the questions 14, 18, 12, is this looks like uniform or not? I understand. Now, so this is one of the chi-square test. Even though at least understand in an interview, someone asks you what's meant by chi-square test, would you explain or not? Still you're not convinced him, just give this example. Just give this example. Filter method. Now let's go to the wrapper method. Just one moment, give me 5 minutes, we'll close. In wrapper method, you know what is meant by wrap, guys? I mean to say that if I build the model, one attribute, independent variable, one dependent variable. Can we build model 1 or not? Can I build A, B, and T? Can I build model M2? One independent, one dependent. Two independent, one dependent. Three independent, one dependent. Can we build multiple models or not? But if I build multiple model, the time consumption is very high. So that's why we cannot go for this method, guys. So that's why in real time, we use two techniques. The first one is backward eliminations, which we are going to understand tomorrow. First, we understand multiple linear regressions algorithms, we'll see what is R square, what is adjusted R squares, and how to check what is hypothesis testing. Tomorrow sessions we can understand, guys. Are you clear or not? Okay, that's it for today. And I will share all those things and see you guys. And one moment, I'll mention this one. So anybody tell me what we completed, guys? We covered supervised learning, and I called as RUCTUR structured data. Okay, we have regressions and classifications. In regressions, we understand linear and non-linear. Okay, in linear, we discuss few set of, I don't want to mention all those things, linear algorithms and non-linear algorithms. And then we talk about like simple linear. We started simple math behind how to compute slope equations, and how to get predictions points, isn't it? And how math would help you, how math would help to plot best fit line, isn't it? And we understand some salary projects data set using SLR, simple linear. And then we build house price predictions using SLR model. I'll give you some task. I wanted to know that in code, how to outlier detection code. I gave you some assignments to you. Are you guys clear or not? Okay, so that's what we covered. Is there class on 1st May? Why, what happened 1st May, Paul? Your birthday? Just kidding. Okay, 1st May, what happened? Any holidays? Labor Day. You are in US? One moment. No, actually, Paul is good. I think, yeah, I think Paul, are you in US? If yes, then I don't think so. No, Paul, apology. Unmute you. I know it's office holiday on the day. Yes, Paul?
No, I office holiday. I'm in India only, Bangalore.
Oh, okay.
Office holiday.
I know your office is holiday, but night is not holiday.
No.
Okay, thanks. Okay. I thought your birthday, man, and you're trying to present the treat from Bangalore to here.
Not really.
Okay, good. Thank you. All right, have a good day, guys. Bye. Ah, your birthday? Okay, that's fantastic. Okay, thank you. Okay. I'm sharing all those things. Please work on it. Thank you, guys. Are you guys visiting to lab or not?